I always have trouble with that word, Bowie, B-U-O-Y. Cosmologists have since tried to use the Big Bang to explore other consequences of matter at very high density and temperature. So another thing is, of course, at this point in the universe, it's not as high density and it's not as high temperature. When the Big Bang was happening and when the universe just got started, it was a very hot, dense, high temperature environment, very different environment than what we see now. Okay, it was called radiation dominated environment. Lots of photons, electrons, positrons actually were sort of in that cosmic soup, if you will, and lots of hot, dense, just crazy stuff going on. We wouldn't have been forming at that time. We are part of the now, or a much more current universe. In that past, it was very different. Okay, very, very, very dramatically different. So in that very high density, high temperature environment, in this activity, the Big Bang exploits the connection between the world of the very large and that of the very small. So this is another thing, is that because the environment then was so extreme, it's almost like the Big Bang has this ability to unify the world of the very small and the world of the very big, because the very big was part of the very small at that time. The universe was smaller then, right? The length scales were different. It was hot, dense, temperature, high temperature, all not expanded as much as we are now. So it's almost like everything was part of that same cosmic soup, that it's like everything is more unified at that time. So Big Bang, in other words, is a model that's kind of exploiting that, well, things could have been very, very unified back then, and things are, of course, very different now. So it's almost like a way to explain it away, if you will. The further into the past we travel, the smaller and hotter the universe becomes. The smaller and hotter. Keywords smaller, keywords hotter, right? I already said it was very hot. Temperature's very, very high compared to now. And smaller is the other thing, right? Because at this point, we have expanded a lot. Because of dark energy, there is this anti-gravity phenomena in the universe that makes it expand. Literally, the distance between 2 points get bigger and bigger over time at large scales in the universe, which is called the expansion of the universe. Dark energy is what is quoted as being the phenomena that enables this. It works against gravity to do that. But back